the word nano. It's four letters. Nano. Can you say nano?
Nano.
Nano. Okay.
Nano.
So when I say nano, you say nano. Nano.
Nano.
Nano.
Nano.
Okay. Now, nano is a prefix. It's really, really small. Can you do this right here? Really, it's really, really small. I can't really see it with my naked eye. It's really, really small. So can you say nano?
Nano.
Is really, really small.
Small.
Okay, so when I say nano, you say small. Nano?
Small.
Nano?
Small.
Okay, let's try that again. So when I say nano, you say small. Nano?
Small.
Nano?
Small.
Okay, and guess what, boys and girls? The thing is, our bodies are made up of things that are really, really small. Really, really small. Okay? We can't actually see it with the naked eye. Okay? We need special instruments to see things. So if I cut myself and you see some blood and I can put it on a microscope, okay? I can see it with my eyes, but if I want to see it at a much smaller level, I need an instrument like a microscope to see something. Okay? And then if I want to see the cells itself, I can actually use an instrument that's really, really small. Okay? Now, so what we have today, we actually have 4 activities for you to do. Okay? Okay, and I want you to repeat after me what it is. So we have heat transfer. Say heat.
Heat transfer.
Okay, so heat transfer. Okay? That's the one activity. Okay? Everybody repeat after me. Say oobleck.
Oobleck.
Sounds interesting. Oobleck.
Oobleck.
Say oobleck.
Oobleck.
I wonder what oobleck would be about. Okay, so that's number 2, okay? So I want everybody to go to a different table and we'll rotate, okay? So the 2 that we just did, heat transfer, say heat transfer.
Heat transfer.
The other one is oobleck.
Oobleck.
And guess what? The third one is, say nano fabric.
Nano fabric.
So what do you think nano fabric is? Some type of some fabric that's really small, right? Yeah, so you'll get to do something like that. The other, in that same category, you're going to do the, say, lotus leaf effect. Whatever that is, you're about to see, okay? All right, and then the other one is, it's a special instrument. It's a model of what scientists use to study things that are really, really small. Say TEM.
TEM.
Or say TEM. Say TEM. Very good. And what TEM is, say transmission, electron, microscope. Very good. Are you guys ready?
Yes. Yes.
All right. We are ready. Okay, so go to the table open-minded. Don't be scared to touch anything. If you have a question, certainly ask a question. But I want you to use your eyes, okay, to make, what do you think is happening, okay?
Okay.
All right, give me another high five. High five. Are we ready? All right, I'm ready too. Ready for it. Ready?
Yes.
Ready? Are you ready to explore? All right, we're all yours.
Okay, so this activity was the nanofabric activity, and the scientist is explaining to the students that there are 2 different kinds of fabric. One is nanofabric and one is made of cotton. The one that is a nanofabric is water resistant, and the one that is made of cotton is not water resistant. The water will soak through. And she was just giving them different ways to see the water soak through, and actually making them a part of the experiment by allowing them to actually feel the fabric and touch it and just really get a feel for what's going on, for them not to be scared or nervous about the activity. She did allow them to squirt the water on there, and she gave them a chance to take turns, and she just explained to them the difference between nano fabric and how it's water resistant, and cotton fabric and how the water would soak through and the soak up in the fabric.
Now, have any of you ever had?
And next she's going to actually use the leafy greens as a example of how nano fabric or nano material works, because the water she's going to drop on there is just going to roll right off of the leaf, and it's just going to just giving the kids another example or another way to understand how nano fabric just does not soak up any water. It'll just roll right out. And she also used she did say the name of this leaf, but or this plant, but I can't remember what it is. I know one was a collard green leaf, and then the other one I can't remember the name of it.
This is called the lotus effect because there are these leaves called lotuses, and whenever they get wet, it just rolls right off, and they never get dirty. It's really weird, and that's because of nano stuff. Really, 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 really small. There are these little bumps all over the leaf, and you can't really see them or feel them, but it means that water just comes right off.
Can they touch the leaf so I can feel the texture? Feel how it feels. Touch it. Jalea, you want to feel the leaf? Touch it. Messiah, touch it. See how it feels. So in this activity, this was the OOBLECK egg drop, and she basically had about 3 activities in one. She used the real eggs and the fake eggs to drop and see which one would break and which one would not break based on how heavy they were in gravity pulling them. And in this clip, she is just allowing the students to touch the OOBLECK and feel it and just get a feel for the actual experiment. So now she's putting the egg in the bag and getting a plastic egg, and she's gonna take them to the side and actually drop them. And she just explaining to the students that the real egg is the one that's gonna break because it has no protection and it's heavier because of the yolk in the inside, and the plastic egg was lighter. Now, in the next portion of the experiment, she's going to put a real egg inside of a bag of oobleck and drop it. And she's going to see if the real egg breaks or not. In this particular experiment, the real egg did not break. And it was because it was protected by the oobleck and it had cushion. So as you can see, when she pulls it out of the oobleck, it is still intact. It is not broken. And I forgot to mention that this was the soft oobleck. She made 2 different batches of oobleck. That's why she has 2 different bags. One is a soft oobleck and the other one is a pretty firm, hard oobleck. So now she's going to use the firmer oobleck, and different variables go into this experiment because one, we have to remember that this is a hard oobleck, and so it could make the egg break. Also, we have to keep in mind the oobleck is kind of used as a cushion, so it might not break the egg. And come to find out, the egg did break, and her hypothesis was because the oobleck was firm. It did not act as a cushion. It actually helped in breaking the egg. So the next activity is exploring properties heat transfer, and this gentleman has two different blocks. One is made of foam, and the one is made of aluminum, and one is cold and one is warm at room temperature. And so basically, he's gonna put the piece of ice on each block to see which one melts the ice.
As you can see, this one is not being melted. This one is melting. The reason that this one melts is because all the heat from the room conducts to the aluminum block, which transfers it to the ice. Because the aluminum block is a good heat transfer and a good conductor, and the foam one is not. Therefore, it is not conducting the heat. That is why the ice is staying in place. Now, this is graphite, which is also another heat conductor. It is mostly used in computers to keep computers cool. And what happens is when you warm your hands up, and then you take the graphite, it transfers the heat from your hand to the graphite, which when you touch the ice, it begins to melt the ice and go into the ice.
Wow.
Once again, that's because the heat from your hand goes into the graphite, which transfers into the ice.
So in this activity, the students are going to be using the transmission electron microscope to actually explore and find the shapes. And basically, they have to look through the little hole, and they should see shapes based on the shadow of light.
This is a model of the TEM. We have the TEM. So they will put a sample at the bottom, and then they shine. They have a beam, typically like a beam of electron, but we got a beam of light shining through the sample. And what happens is, there's gonna, when the light shines, it creates a shadow. And so we can kind of figure out what that shape is with the. So what we're gonna do is we can use this Play-Doh to make the shape that you're seeing. So you gotta look through here. Do you see a shape? Bob shapes here. What is this like this? Yeah, how many shapes
Good job, Brooklyn. So at the end of the event, they had a story time with the students, and they read Horton Hears a Who, and it was actually a interactive reading because some of the students came in and acted out the parts, and they had props, and it was just very fun and a good way to end the camp. And so I just want to say thank you to Jackson State University, Department of Chemistry, and Dr. Davis for coming over and helping the students experience science and just opening their minds and letting them know that it's just so much out there and to have fun with science. So thank you very much. Thanks guys for watching, and I'll see y'all in the next video. Bye.